Hello students, good morning all of you. Today in our video, we want to learn about the kinematics. So this kinematics chapter is very important for both JEE and NEET and also board examinations. So today in this video, we have to learn about the rest, motion and displacement distance. Okay, so let us start our topic. Kinematics. So in the meaning of kinematics, kine, it is meaning that motion of an object, and the matics, it is meaning that mathematics. So here the total meaning it is motion of an object in the mathematical formations, right? That is the kinematics. So here in this chapter especially we have to learn about the motion of an object. Which type of motion is here? That motion it is one-dimensional motion. Which motion? One-dimensional motion. Right? So here one-dimensional it is meaning that a particle which is moving in a straight line. Which is moving in a straight line motion. So this is the straight line motion. In physics, the straight line motion it should be called as rectilinear motion. Rectilinear motion. Rectilinear motion. And also motion should be studied in 2D also. 2D. The two-dimensional motion should be studied in case of projectile motion. Projectile motion. So in case of projectile, already you know that a particle which is projected with some angle to the horizontal surface, not except 0 or 90 degrees. Any other angle it should be called as projectile. So this type of motion should be in 2-dimensional. Okay. And circular motion. If a particle is moving in the circular path, that motion should be understanding by the 2-dimensional motion. And also the motion should be in 3D also. 3-dimensional. The 3-dimensional motion it is nothing but random motion of the particles. Random motion of the particles. Random motion. So it is meaning that the motion of air molecules. Motion of air molecules or the gas molecules. So that should be the 3D. So especially in this video we have to learn about the one-dimensional motion of objects, that is straight line motion, or it is rectilinear motion. Okay. So before going to know about the motion, just we have to know about the rest. Okay. So what is meant by rest? When we are called a body is at rest. So let us start. Rest. What is meant by rest? If a particle, if a body will not change its position, with respect to time or fixed point. So this fixed point is known as the frame of reference. So frame of reference, it is meaning that where we have to see or observe a body. So that is the frame of reference. So if a body will not change its position with respect to time, then that body is said to be in rest. For example, if a particle P is located at point A at time t is equal to 0, and after time t is equal to 5 seconds, you have to see that object or particle, it will be having at the same position. And after t is equal 10 seconds, you have to see that particle, it should be located at the same place at point E. So this type of phenomenon is called as the rest. Because of, if the time will be increases, the particle will not be change its position. Okay, wherever you have to stay, that is fixed point, the position of the particle will not be changes, that is the rest. So a body, if a body will not change its position with respect to time or with respect to the fixed point or the frame of reference, then it can said to be in the rest. So now we are coming to the motion. So what is meant by a motion? So here, if a body will change its position, if a body will change its position, with respect to time or frame of reference, so then the body can said to be in the motion. If a body will change its position with respect to time. For example, if a particle P is at A at time t is equal 0, and after t is equal 5 seconds, you have to observe that the particle P is at point P, and after t is equal 5 seconds, 10 seconds, then the particle P is at point C. So this is the position of the particle with respect to the time. So here the position will be changes with respect to the time. Then this particle P is in the motion, is said to be in motion. So if a particle will not be changes its position with respect to the time, then it can said to be at rest. If the particle will be changes its position with respect to the time, then it can said to be in motion. So this is the variation between the rest and to the motion. Understand? Right. So now we have to learn about the displacement and the distance of a body. Right. Especially in this kinematics chapter, we have to study about only the motion of the bodies. So to study about the motion of the body is called kinematics. To study about the reasons behind the motion of the body, that is called dynamics. Okay, that is the variation between the kinematics and dynamics. So dynamics is to study about the reasons behind the motion of the body. Got it? But in kinematics, we have to study only the motion of the body. There is no need to know about the reasons behind the motion. Okay, so that is the kinematics. Right. Now, distance and displacement. So what is meant by distance and what is meant by displacement? So here, distance and displacement. So distance, it is the very important. These are very familiar words in our daily life. So you must know about as a physics student, you have to know very well about these two terms. So distance it is the total path length. Distance is the total path length traveled by the body. Total path length traveled by the body. Total path length. So if a body is moving, how much distance, how much total actual path length should be traveled, that is the distance of an object. In case of displacement, the displacement, it is nothing but if a body must be change its position, then only displacement will be occurs. If there is no change in the position of your body until it have moved some distance, then if there is displacement is equal 0. If there is no change in the position of your body, there is no displacement. There may be a chance to having the distance. How it is possible, let us see. Right? Displacement. So displacement, it is nothing but the shortest distance, the shortest distance from initial to final points. Initial to final points. So this is the displacement. So distance has no direction. It has no direction. Hence it can said to be scalar quantity. Very important. Scalar quantity. So distance is the scalar quantity. Displacement having both magnitude and direction. Hence it can said to be a vector quantity. Very important. Right. First suppose, so here you have to, a particle P is at point A. It is moving up to point B. Okay. So it wants to reach point B. Then it chosen the path here. This is the path 1. And one more path it is traveling, that is path 2. And another path, that is path 3. So these 3 are the ways to reach the particle P from point A to B. Okay, right. So for suppose particle along with the path 2, it will be reaches point B. Then this is the distance. Because of the distance, it is equal the path length traveled by the body. Maybe it is the distance, it is equal 20 meter. Let it be 20 meter. And in case of first path, the total distance covered by the particle, that is d is equal 15 meters. And here, what is the displacement in this case? The displacement, it is equal the shortest distance from initial to final. This is the initial point and this is the final point. The shortest distance, which is nothing but a straight line, the shortest straight line between the initial and final points of your body. Right? So that is the displacement. Here, this is the displacement. So specifically in third path, the distance of the body, is equal how much? For example, distance d is equal 10 meter, let it be. And also displacement is equal how much it is? 10 meter, no doubt. Here in third case, the distance and displacement both are equal. Okay. So distance is may or may not equal to the displacement, of the body. Distance and displacement may or may not equal to the displacement of the body. But one more thing, it is distance is always greater than to the displacement of the body. Distance is always greater than to the displacement. Displacement, why? Because less than the displacement, it is nothing but the shortest distance between the initial and final points. That is the displacement. So distance, it is the total path length covered by the particle. So distance must be greater than to the displacement of the particle. So let's see another example for the better understanding of the distance and the displacement of a body. Okay, right. How we can For example, if a man can walk 3 meter east and 4 meter north, then what is the distance and displacement? What is the distance and displacement? Okay, here if a man can walk 3 meter of east and 4 meter of north, then what is the distance and displacement of a man? So here, for suppose here, if a person is here, he moves east. So this is the north, south, east and west. Okay. So 3 meter as east and 4 meter north and 4 meter north. Now person is at here. This is A, this is B and this is C. So what is the distance and displacement? So the distance, it is nothing but the total path length covered by the person. Total path length. Distance may be called as path length also. Distance, the total path length, it is equal, how much it is? AB plus BC. AB plus BC. It is equal 3 meter plus 4 meter is equal 7 meter. This is the distance of the person. And what is the displacement here? The displacement, it is the shortest distance between the initial and final. This is the initial point and this is the final point. The shortest distance between these two, it is the shortest distance. So this may be hypotenuse to this triangle. From the Pythagoras theorem, we have to solve it. Side square plus side square under root. It is equal, what is that? 3 square plus 4 square. It is equal 9 plus 16 to 25. Under root 25, it is equal 5 meter. So here, this is the 5 meter. 5 meter is the displacement. Distance is the 7 meters. So here distance is not equal to displacement. Distance is not equal displacement. Okay, clear? Right, this is the process. You have to find the distance and displacement. And one more example you have to see. So similarly, if a man can walk 4 kilometers, if a man can walk 4 kilometers, 4 km to the market and turn back 2 km in the direction of his home. Find distance and displacement. Right. So a man can walk 4 km to the market. So for suppose here a man can walk 4 km to the market. So here it is the market. How much distance he traveled? 4 km. The distance, it is equal 4 km. Right? And this is at home. He started from the home. This is the home. And after he come back, he turned back 2 km. So this is the 4 km and again he come back 2 km. So here 2 km. Now person is located at this point. So what is the distance and displacement here? So here market is at the 4 km, of distance, and he turned back 2 km. He is at midpoint. The distance, it is nothing but The distance, it is meaning that the total path length covered by the person or the total path length traveled by the particle. So distance, it is equal, distance is equal total path length. How much distance he traveled? So at first he traveled 4 km and plus again he traveled 2 km, come back. So then it can be 4 plus 2, it is equal 6 km. The distance traveled by the man, it is 2 km, 6 km. And the displacement of the person, displacement, it is equal, how much displacement? The shortest distance between the initial and final. This is the initial and this is the final. How much shortest distance he is here? At initial 0 and here the final point, it is 2. Okay. So the shortest distance between the initial and final point. So final, it is the 2 km minus 0, it is equal to 2 km. Or in the 4 kilometers he turned back 2 kilometers, and how much distance he will travel to reach his home? 2 km. 4 minus 2, that is 2 km. So the displacement of the person, it is 2 km, and distance traveled by the person, it is 6 km. First, suppose if a man can walk 4 km, turn back and turn back 4 km in the direction of home, and what is the distance and displacement here? The distance, it is total path length 4 plus 4. 4 plus up and down, to and fro, it is 4 and 4. 4 plus 4, that is 8 km he traveled. But in displacement, and after traveling 8 km, he is at position, initial position. There is no change in his position. If there is no change in the position, there is no displacement. Okay. So then the displacement of the person, it is equal 0. This is very, very important. Understand? Right. And one more example you have to see. In a circular manner, if a particle is moving from the origin having the radius r, from point here to this point, okay, from A to B. So what is the displacement of the particle? So displacement, it is initial point to final point. So this is the AB. AB is the displacement. AB is equal displacement. How we can find the displacement? So here this is also radius r. Okay. So then this is hypotenuse, side square plus side square from the Pythagoras theorem. Then you have to displacement AB is equal under root of r square plus r square. It is equal to r square. It is equal root 2r. So this is the displacement of the particle here. Displacement. Okay. Displacement of the particle. And now, if there is a circle, if a particle can be moves along with the circle, okay, from the radius of r A2, and it will moves from this side. This is the B. So this is also radius r. So what is the displacement here? The displacement in this case, it is equal displacement, the shortest distance between initial and final. This is the final and this is the initial. This is the shortest distance. There is no hope to any other ways. So the displacement, it is equal r plus r. It is equal to r. R plus r is equal 2r. So this is the displacement in this case. For example, if there is a particle moving in the circular path from point A to point B. So here having the radius r, and this is the theta 120 degrees. This is the point B. Now we have to find displacement. What is the displacement here? So here in this case, the displacement of the particle, that is the displacement, it is equal AB. AB, it is equal 2r sin theta by 2. 2r sin theta by 2. So this is the formula you have to remember this. Where theta it is equal 120 degrees, where theta by 2 is equal 60 degrees. Where therefore displacement it is equal 2 into r into sin 60. Sin 60 it is equal root 3 by 2, and 2 will be cancelled out. It is root 3 r. So displacement of the particle with some angle 120 degrees, there it is root 3 by r. If there is an angle theta, for suppose this is the point P, if there is an angle theta, then the displacement it is equal 2r sin theta by 2. So this is you have to remember. How we can find 2r sin theta by 2? Let us see in the vector formation. So that is equal, let us see how we can find the 2r sin theta by 2. Let it just to be, so if a particle having the radius of r, and here the particle A to B, and this can be made an angle theta. So here AB is the displacement, AB. So here from the magnitude of the resultant vector, where AB is equal under root of r1 square, it is r square plus r square. It is equal a square plus b square plus 2ab cos theta. 2ab cos theta. From this is the magnitude of the resultant vector. From this we can get r square plus 2 r1 r2, it is r into r square cos theta, where it is 2r square plus 2r square cos theta. So 2r square will be common, 1 plus cos theta. So from the trigonometry formulas, 1 plus cos theta is equal 2 sin square theta by 2. 2 sin square theta by 2. So just substitute here, it is equal under root of 2r square into 2 sin square theta by 2. Okay, let, so 2 into 2 4, and r square, it is 4r square sin square theta by 2, 4r square sin square theta by 2. Okay, and then the squares will be cancelled out by root, then 2r sin theta by 2, which was already wrote here, that is the displacement. Very, very important. So displacement it is equal to r sin theta by 2. Okay, if there any angle, if theta will be given, you should write that if theta is equal 120 degrees, already we have seen that displacement it is equal root 3 r. So this is the variation, we have to find the distance and the displacement. So if displacement is 0, there is distance. Here you have to observe the distance will not be equal to 0. But displacement is maybe equal to 0. There is a chance to equal to 0, but in case of distance it is not equal to the 0. Distance is always greater than to the displacement of the body. Okay, in some cases distance and displacement is always equal, in some cases especially. Okay, so dear students, this is our video today's, and I hope you have to understand very well. If you like the video, share to your friend and subscribe to our channel. Thank you. Bye bye.